So if it is shared locks, that is read lock, and if it is exclusive or X lock, then that is considered as what? Write locks. When it comes to the read item of X or this shared lock, read the value of a item by locking its resources. So when all the possible locks have been acquired, the transaction reaches to the lock point. Hello everybody, a warm welcome to one and all. Welcome back to the session 3 of Unit 4, and we are dealing with the BCA's 4th semester subject called Database Management System. As we all know that in short it is Dbms. I am Rohini TS, Department of Computer Science, Vidhyaashram, 1st grade college, the Temple of Excellence, MYSURU. So before getting into our today's session of session 3 about this concurrency control, let me just recall the previous content. So in the recap of the previous session, we got to know that what do you mean by concurrent execution of a transaction. So in order to maintain that, we have a serializability here, and under the types of this serializability, we have result equivalent schedule, conflict equivalent schedule, and also at last we have view equivalent schedule. So these are the 3 types which comes under this serializability. So why this serializability will going to be used? It's a mechanism or a procedure in order to identify whether the null schedules are working either in a serializable manner or not. So in order to ensure that we have this serializability. So in our today's session, we are going to see about this concurrency control. Already we know about concurrent execution, right? So if more than one people are trying to accessing a same content at the same time, so if all are trying to access the same data, then we are going to call that as a concurrent execution. Then why that concurrent execution control is required? So if you are not able to control this concurrent execution, then that may going to lead to the inconsistency of the data. So in order to avoid that, we have this concurrency control that can be done with the help of this locks as well as timestamp ordering protocol. So in this locks, we have 2 phases of locking protocol, and also we'll see what are the drawbacks that we can face when it comes to the locking protocols. So we'll see about all this regarding concurrency control in our today's session. Let me get into the session that is with respect to this concurrency control. First, we'll see what you mean by this concurrency control, why it is required. So the management procedure that is required for controlling the concurrent execution. Why we require it? Why the concurrency control is required? Mainly in order to control the concurrent execution of the operation that takes place on the database. So whatever the operation or a transaction that we are having in a database, if it is concurrent execution is happening there, then maintenance of that concurrent execution is required. So if it is in the uncontrolled form, then we can't have a control over the data consistency. So in order to maintain the consistency of a data and in order to ensure this isolation property, already we know that every transaction of a database should follow this ACID property. That means atomicity, consistency, isolation and durability. Then only we can say that that is more efficient way of doing a transaction. So now we'll see, like you got to know what is concurrency control. So now we'll see why this is required. That means what is the need of having this concurrency control? Mainly in order to guarantee the serializability in concurrent transactions. So whether it is serial or non-serial schedule. So whenever having this concurrent execution, at the time there must be a serializability. In order to ensure a serializability is there in concurrent execution or not, then we require a control over that concurrent execution. And also mainly to ensure isolation property of concurrent transaction. So if you are doing some changes to the data of a T1 or a transaction 1 should not affect the data of transaction 2 or should not get affected by any other transaction. Then only we can say that is what isolation property got satisfied. So in order to ensure consistency, serializability as well as isolation in the transaction of a database, we are going to have this concurrency control. Then how we are able to control this concurrent execution? What are the methods we have? So here you can see that we have techniques in order to control this concurrent execution. Out of that we have log based and also we have one more, that is timestamp based. So here what about this log based? In this, locking data items and thus preventing concurrent transaction from accessing. So if I am blocking a data in order to access, then we may release that lock, or we can give access to the data one after another. So serializability is also going to be ensured there, and isolation property can also be accomplished. So that this lock based technique is also used in order to control this concurrent execution. And also we have a timestamp based. So instead of waiting for a long duration, if we are giving a timing for each transaction, then that would be better than waiting in the queue. So here in the time based concurrent control, it will execute the transaction based on the time based ordering. So as per the order has been given as per the time, based on that the execution will going to takes place. So if they are saying T1 should takes place for 10 seconds, then it will going to take for the 10 second, and T2 transaction will going to hold 2 seconds of transaction. So at that time it has to come and it has to execute its transaction in the database. So these are this is regarding concurrency control and why it is necessary and what are the technique we have in order to control the concurrent execution. So this is very important topic for your exam point of view. Fine. We'll move to the next point here. In that first we have a lock base. So now we'll see what do you mean by this lock. So here lock is a variable to control access to the data item. Whatever the data item that we have in a database should be controlled by its accessing by the help of a variable. Then we are going to call that variable as a lock here. So this will going to help in order to control the access to the data. So if I am locking any of the data that can't be accessed by the user at the same time, that means more than one user cannot access the same data at the same time. So then only we can have a control over the concurrent execution. So here a transaction must get a lock before operating on the data. If I wanted to operate on the data, first in prior I have to lock that data. Then only my place will be there in order to access the content of data. That is one of the methodology that we are following here. Then what are the types of locks we have? So lock is a variable that is helping us in order to lock the content which we wanted to access, right? Then we have two kinds of lock here. One is shared locks, and that is also considered as read locks, and I wanted to perform one more operation called write. So for that also we have a exclusive locks, that is considered as what? Write locks. So if it is shared locks, that is read lock, and if it is exclusive or X lock, then that is considered as what? Write locks. So we'll see about this read locks. As the name indicate, we are performing an operation called read, right? So obtained if you want to only read an item. So we can have this shared lock or a read lock if you wanted to perform only read. That means I wanted to read the content whatever we have in a database, and other transactions are allowed to read the item. So other than that, any other transaction is going to read the content. So if you wanted to read an item from the database content, then you have to lock that data. So in order to lock that, we have to use this read lock or shade of S locks. Next we have a exclusive lock here. It's all related to writing operations. So if I wanted to update some content to the database, or if I wanted to modify some content to the database, instead of read, I have to go with a write lock. So I'm locking the data which I wanted to update in a database. So it will be obtained for updating a data item. So why we are going to use this exclusive lock or write lock? Mainly to updating a data item, and single transaction exclusively holds the data item. So whenever we are updating, other than that operation or a transaction, any other transaction will not going to be entertained. Fine. This is regarding locks. So next, here you can see that we have certain instruction in order to have a lock. So for example, you wanted to lock a data item of a database, then you have to follow certain instruction, that is regarding lock instruction. So here you can see that lock item of X has 3 states. So if you are locking a content, that can be of 3 states. Already we know about a read and write, which is the one more thing, that is unlock here. Fine. We see here read lock of X, that is shared lock. It is always related to what? Read operation. And if we have write lock of x, then that is exclusive lock. So if it is exclusive lock, then it's related to write. So whenever we are holding a lock for the either purpose of read or write, at last it needs to be unlocked. So there we have a unlock of x. So when it comes to the read item of x or this shared lock, read the value of a item by locking its resources. And also here we have a write item of x that will updates the value of the item. In order to read a value, shared lock. So in order to update the value of that item, then we require this write item of x or exclusive lock. So you have to understand one thing, whether we are doing read or write operation, that doesn't matter. So at last what we have to do, so we have to unlock after the read and write operation, whether we are using a lock for shared lock or exclusive lock, whatever it could be. So we have to unlock it at last. So why? Because another transaction may be waiting, another user wanted to access a content. So it is necessary to have this unlock of key after the read and write operation. This is regarding lock instruction. And also here we can see that we have a two-phase locking protocol. So in this two-phase locking protocol, how it will going to work, like in order to ensure more security of a data and in order to control the concurrent execution, there we have a two-phase locking protocol. Mainly it will going to define the rules to lock and unlock the data items while operating the data item. So what this two-phase locking protocol specifies, always you need to understand one thing, when it comes to the protocol, that always specifies some standards and set of rules and regulations. So you need to follow this set of rules and regulation in order to have a lock or unlocking of a content whatever we have in a database. So always it specifies the rules in order to lock both as well as the unlocking of a data item whenever we are operating the data of an item. So here mainly this whenever we are following this protocol, it ensures the serializability. So whether it is serial or non-serial scheduling, so though it is a non-serial scheduling, it has to come under or it has to execute the transaction as per the serial methodology. So whether it is performing or not, in order to check that we have a serializability. So in order to ensure serializability, we can have certain rules in order to perform read or write operation, whatever we are doing, and at last we have to unlock that data item. So for that we have a standards called two-phase protocol or a two-phase locking protocol. And mainly it contains of two phases. One is growing phases and second one is shrinking phase. So as the name indicates, growing phase. So always when this transaction gets started, it has to grow. So once operation is done, either read or write, it has to come back to the shrinking phase. So what will going to happen in a growing phase? We'll see now. A transaction may obtain locks. So in growing phase, what we can attain? So in the growing phase, we can obtain a locks. That means we are taking a locks in order to lock the data item of a database, and transaction may not release the locks. Why? Because in the growing phase they are doing the transaction. In between we can't relieve or we can't release any of the locks here. So in the growing stage we are not at all going to release any of the locks. Whatever the data has been locked with the help of exclusive or with the help of shared locks, so that will not going to be released at the time of this growing phase. So when all the possible locks have been acquired, the transaction reaches to the lock point. So whenever we are having all the operations or whenever all the possible locks have been acquired a transaction, when it reaches, it will going to reaches to the lock point. That means all the resources or a data item will going to be locked by the particular transaction. So all the resources or all the read and write operation, whatever the lock that you have attained, so everything will be under this lock point. Then Just reverse to that. So here we are attaining or we are obtaining a locks. We are not going to release a locks. Then when we have to release a locks, so that will be in the phase of this shrinking phase. So when all the transaction is got over, then it's mandatory to release the locks after the lock point. So once lock point is done, that means all the transaction read and write or update, everything is over, then it is necessary to unlock that lock. That means the releasing of that locks needs to be takes place after this lock point. So in this phase, transaction may not obtain locks. Why? Because they are releasing a locks. In order to obtain a locks, we require a growing phase. In order to release the locks, we have this shrinking phase, right? Upgradation of lock, whether it can be read or write, it's not possible in shrinking phase. So why? Because here whatever the lock is done or lock point is reaches, then only we are going to have this shrinking phase. So here we are not going to obtain or we are not doing any read or write operation by locking a data item of a database. So here it is not possible in shrinking phase, but it can happen with this growing phase. So here you can see that here we have a set of time, that means how much time it is taking that in order to give a log, how much time it requires, that specifies the time here, and T begins, that means transaction will going to be begins when the transaction is getting begin, at the time the lock is going to be attained, then we can call this as a growing phase, right? All the operation is going to perform here. Once it reaches to the lock point, once all the transaction got over, then they have to release the lock. That means lock is released. So when we are releasing a lock, then it will be in the shrinking phase. So once the transaction begin, at some point it has to end. So this specifies the T ends. This is how this two-phase locking protocol will going to work. Fine. We have two phases, growing phase, shrinking phase. So here you can see the example here. We have a two transaction named T1 and T2. We are performing both locking and unlocking. So as you all see here, read lock of y. That means I am holding a variable called y, or we are locking in data item called y for the read operation. That is shared lock we are using here, and read item of y. So once it got locked, then only we can read this, then write lock of x. If I wanted to do any of the changes or updation, write lock of x, there we are going to perform it. After that, unlocking of that y data item is taking place. So whether it is read, write operation, anything it can be, at last that needs to be released. So here you can see that we have locked this y and unlocking of y is taking place, and we are having this write lock of x, and at last I need to unlock it. Why? Because another transaction may be waiting in order to access the same content. So it is necessary to do the locking. Once the transaction got over, then it needs to be unlocked. Fine. This is regarding example that you can expect for this two-phase locking protocol. So next here we have certain disadvantages by having this locking protocols or two-phase locking protocol. What are those? You can see here, it may lead to the deadlock. So for example, what do you mean by deadlock here? First you understand, even we have only one track. Okay, so we have only one train track. So here one train is coming from this way and another train is coming from this way. You just imagine we have only up to this place of track we have. So this situation, that means even it can't move forward, So if does so, then the accident will going to takes place, right? So if both are waiting for another train to go to reverse, and if they are waiting for the resource to be released, then we are going to call that situation as a deadlock. So unknowingly another data item is waiting in order to access or to read, write operation, whatever it could be. So if they are waiting for a long duration, even they don't know whether it is going to be available or not, then that kind of situation is called deadlock. So here deadlock is a condition where two or more transactions are waiting indefinitely for one another to give up locks. So in order to release a lock or in order to give up a lock, if one transaction or two or more transaction is waiting for a same data item to be released for a long time, then we are going to call that as a deadlock. It is a condition condition where two or more transactions are waiting indefinitely. I don't know at what time it will going to release. So if they are waiting for a long time than the specified time for one another to give up the locks. It's like a jidda jiddi. So you just release the lock or you just release the lock. Both are not at all ready to release the lock. Then other transaction is waiting for that transaction to release the lock. That scenario is considered as what? Deadlock here. Even the deadlock situation can be occurred when we have this two-phase or a two-phase locking protocol. So here cascading rollback is possible under this two-phase locking, and also deadlocks and starvations are possible. That means these two situations, whether they are waiting for a indefinite time or infinite time, they are waiting for the resource to be released, that may lead to the starvation and deadlock. So these are the drawbacks that we have when we are having this two-phase locking protocol, right? This is regarding concurrency control and methodologies. So next we have one more type in order to control this concurrent execution or to control a concurrency. So in that we have a timestamp ordering protocol. First is related to locking. We are going to lock a data item, then we will perform read or write operation. Once it done, unlock should be takes place. If you are not unlocking it, then deadlock or starvation will going to happen. Then how this timestamp ordering protocol or ordering method will going to work for the concurrency control? We'll see here. The timestamp ordering protocol is used to order the transaction based on their timestamps, instead of waiting for a long duration. So they are just going to specify the timestamps. The timestamps is always be in the ascending order of the transaction created. For example, T1, T2, T3. So here we have a three transaction, T1, T2 and T3, and this ordering method is also always going to be in the ascending order. So T1 will going to execute its transaction first for certain time, and it will going to release the resources. T2 is going to takes place in the same way in ascending order. So that is always related to what? First come first serve. The priority of the older transaction is higher, that's why it executes first. So if T1 come first, then T1 will going to execute first for certain timestamp. If T3 comes first, then T3 will going to perform its transaction first. So the priority is always for the older transaction. That means first come first serve policy will be there in the timestamp ordering protocol. Mainly in order to determine the timestamp of the transaction, this protocol uses the system time or logical counter. With the help of this logical counter or as the system time or system date, we are going to have this timestamp protocol methodology in order to control the concurrent execution. So you just imagine we have a two transaction T1 and T2. Fine. Let me consider T1 and T2. So if T1 is taking 007, this is a timestamp, and if T2 is taking 009. So at this time T1 has a first priority, right, than the T2. So this will going to be executed first, later T2 will going to be executed. That is one of the examples. So here T1 has higher priority, so it will going to execute first. After that, it will enter the system first. So here we can expect no deadlock. Why? Because they are not having some confliction in between the transaction 1 and 2. Simply T1 will going to execute first, later T2 will going to execute next. This is timestamp ordering protocol. So then how can we get to know the timestamp for either read or write? So there also we have a possibility here, read and write timestamp. That means we have a data item. That data item can be read or can written to the data item. So in order to have two variables, so here we have a two variables in order to keep track of time of access and write, whether I am reading a content or writing a content to the data item. So in order to keep track of that, we have a two variables. Here we have that two variables as maximum of RTS of X. So this is a variable. This specifies the maximum timestamp of transaction that read X. So whatever the parameter that we are giving within a parenthesis specifies the data item. that specifies the data item here. Maximum RTS. RTS is a variable that is related to reading of that content. So here the transaction or a maximum timestamp that can be given to this X data item to be read. So maximum timestamp of a transaction that read X. So just a contradict to this, we have a WTS. It's related to write operation. So that maximum timestamp of a transaction that wrote on X. So this is how we can read and write the transaction or a data item with the help of this timestamp protocol methodology. So here you can see that we have protocol for the read operation. So it will going to be read, and we will check out with whether it is lesser than the maximum write time, then that T1 or a transaction will going to be aborted. Otherwise, it will going to perform the read operation and it will going to take a maximum reading of that variable or a data item called X, and we have to consider this conflict as a read-write conflict. Just opposite to that, we have one more protocol for write operation. Then here we have a write and read operation. So this is how this timestamp protocol will going to helpful in order to have or in order to control the concurrent execution of a data item in a database. I hope you all understood. In my coming session, we are going to see how this deadlock will going to occurs in a concurrent transaction, and also we'll see about the classification of failures of a data item, and then if it is got failed, then it is necessary to recover the data, right? So for that we have certain techniques of recovery of database that I will be discussing in my coming session. Until that, keep learning, keep on growing. Thank you.